Hello, in this presentation we'll talk about drawing points and lines and triangles in OpenGL. We're primarily interested in drawing triangles when we're rendering three-dimensional objects because we'll use triangles to form surfaces of solid objects, but we'll start with drawing points and lines first. And this is taken from section 1.3 of the online textbook of the current draft, so you're encouraged to look there as well. So let's start with drawing points. So let me draw a small picture with x-axis and the y-axis, 2 or 3 points in a plane. So here will be the point 2, 1. Here will be the point 2, 2. And here's the point 0, 2. And we want to just draw these 3 points. Presumably we'd be drawing the pixels at those points. So in C++, what we would do is we'd start off by putting these points in an array. So we've just used an array of floats. So float verts 2, I'll do pairs of real numbers. And the first one is 2, 1. The second one is 2, 2. And the third one is 0, 2. And this also will call this V0, I'll call this V1, and call this V2. And that just loads 6 numbers into an array, and we're treating these as pairs of numbers representing XY coordinates in a plane. So that would be step 1 is create the array. Step 2 is load the array into OpenGL's buffers, into the GPU, the graphics processing unit, in particular the OpenGL buffer. There's 2 buffers. There's a vertex array object and a vertex buffer object. Buffers that we'll describe in a future presentation, or you can look in the book already to see about it. But I'm not going to talk about how to load the array into the GPU yet. And the third step is to use a command like glDrawArrays to issue the draw command. So a command like glDrawArrays, and we want to tell glDrawArrays we're drawing points, and that's used with the parameter gl_points, and I'll say we start with the 0th point and we include 3 of them. That's the 0, 3. But the point I really want to stress here is we're drawing in GL points mode. So it's GL_points all in uppercase, and this tells the glDrawArrays command that there's an array of points which happens to be loaded into the VBO, as we'll find out later on, and we're supposed to draw those 3 points. And I'm going to gloss over for the moment what the points look like, what color they are, and so on. That's treated differently. So in principle, we could create an entire image just by setting each pixel as an individual point to whatever color we want it to be, and thus render anything we wanted. But that would obviously be very awkward to render a picture in terms of just setting every pixel separately. So we want to instead move up to lines next, and let's talk about that. So drawing lines is essentially what we often call vector graphics. This refers to a graphic systems where you draw lines or possibly curves. When you draw curves, they would be approximated as a sequence of very short lines, so short you can't see the separate lines and it looks like a smooth curve. And examples of this would be old-style pen plotters. Pen plotters are, say, big sheets of paper with a pen that goes back and forth, that drags along the paper and draws a line. Or maybe you've seen a laser show, where a laser show has a laser light that shines across a wall, and draws what looks like lines on the wall. Or languages like PostScript and lots of other systems as well are vector graphics based. They essentially draw lines. For instance, a sample type of commands right here on a pen plotter. So for pen plotter, if you wanted to draw the triangle, and I'm talking about the same triangle I had last time. Let me draw that picture again here. So now I've got this triangle here. Here's 0, 2, 2, 2, and 2, 1. And now I want to draw the three edges of the triangle. A pen plotter would do commands like the following. We'd do something like pen up is the first command. That lifts the pen off the paper. Move to 2, 1 would move the pen to be positioned over the coordinate 2, 1. Pen down would drop the pen so it's resting physically on the paper. Move to 2, 2 would move the pen from its current location to the point 2, 2. Since the pen is down, it would trace a line as it moved. Move to 0, 2 would then draw the next line of the triangle, the top line. Move to 2, 1 would draw the third line of the triangle. And this would be the type of commands that are used with a pen plotter. And so another thing in a more modern system, the JavaScript Canvas program, or JavaScript Canvas element, will use commands like the following. It would use something like move to 2, 1. It doesn't have a pen up or pen down command. Instead it has move to move with the pen up, and line to move with the pen down, as it were. Of course, it's a strictly virtual pen. Line to 0, 2, line to 2, 1, and finally you have a stroke command to finish the command. And so this would be how a JavaScript command would be used for this. Now in OpenGL, it's a little bit differently, done a little bit differently. In OpenGL, just here on the bottom of the page, you do GL draw arrays, and then we'd use GL line loop, which, because we're making a closed loop of edges, and we would be drawing 3 vertices total that combine together to make a loop. So this is the OpenGL command. GL line loop is one of the 3 drawing modes for lines in OpenGL, and I'll discuss those in just a second on the next board. So there's 3 modes that OpenGL has for drawing lines. We've already seen GL line loop. There's also GL lines and GL line strip. Let me just illustrate these with examples. So let's suppose we have 6 vertices. There's V0, V1, V2, V3, V4, let me put V5 over here. So I've got 6 vertices, V0 through V5, and if I do a GL draw command, I'll do GL draw arrays. And if I do it in GL lines mode, I'm drawing 6 vertices. What that does is it draws pairs of lines, or draws lines between pairs of vertices. So it draws a line between the first and the second vertex, V0 and V1, the third and the fourth vertex, V2 and V3, and then the fifth and the sixth vertex, which is V4 to V5. You can also do GL draw arrays with GL line strip, again with the same 6 vertices. And what this would do is would add in the connecting vertices. So connect V also, in addition to those 3 lines I already drew, it would draw the green lines connecting V1 to V2 and V3 to V4. I drew that one wrong. There we are. The corrected line is from V3 to V4, and this is just giving a strip of lines. It draws a total of 5 lines if there's 6 vertices. Or you can do the loop, which we already saw on the last page with a smaller example. GL draw arrays, GL line loop. Again, still with 6 vertices. And this would add in the extra edge from the last vertex, V5 in this example. To V0, it would draw a complete loop of vertices, all 6 lines joining up the 6 vertices. So now we'll talk about drawing triangles in OpenGL. And there's also 3 triangle modes in OpenGL. There's the GL triangles mode that draws distinct triangles. And I'll show examples of these. GL triangle fan, which draws a fan of triangles all sharing a central vertex. And GL triangle strip, which draws a sequence of triangles joined edge to edge, and I'll illustrate that as well. So let's start with GL triangles mode. Here we'd again have a GL draw arrays, or other GL draw command. We'll see there's more of them. GL triangles. And I'll do an example with 6 vertices. So there could be V0, V1, V2, V3, V4, and V5. And this draws 2 triangles. We take the first 3 vertices and join them up into a solid filled triangle. And so this triangle will be filled in. And then the second set of 3, and we fill that in as a triangle as well. If there were more groups of 3, we would keep forming additional triangles by the single called a GL draws. And I'm going to put a little circular arrow here. This indicates the direction of the vertices. It's V0, V1, V2 going in counterclockwise direction. V3, V4, V5, they're going in counterclockwise direction. So in this picture, we're looking at the so-called front face of those 2 triangles. So each triangle has a front face and a back face. The back face is the other side. And how do we tell the difference between the front face and the back face? Well, it's from the direction of the vertices. When we're looking at the front side, it's V0, V1, V2 come in counterclockwise order. V3, V4, V5 come in counterclockwise order. If we were looking at the back side of the triangles, you'd see V0, V1, V2 in clockwise order, going instead of going this way, going this way. And you can tell OpenGL to handle, or shader programs actually to be more specific, to handle front faces differently than back faces. You can also tell it to not draw the back faces and only draw the front faces. For instance, if you were drawing a solid figure, you might not want to render the inside of the figure, just the outside of the figure. And so in this sense, it's important for that reason to keep track of which faces are front and which faces are back. And for that, the order of the vertices is important. Okay, so the next example is GL triangle fan. So here we have a GL draw arrays command GL triangle fan, and I guess we can do 6 vertices again. So now what we do is the first vertex, V0, is a common vertex to all the triangles, and the rest of the vertices, V1, V2, V3, V4, and V5 in this example, because there's 6 vertices, are defining triangles that share that initial vertex, V0. So in this case, when we did the triangle fan, we get these 4 triangles, and the 4 triangles, again, I'll draw the little circular arrows for the counterclockwise direction. These things indicate the front faces. So again, as I've drawn it here on the board, we're looking only at the front faces. If we went to the back side and looked, then we see the back faces. But the direction of the vertices on each of these, they go in counterclockwise direction. In particular, the starting one, it's V0, V1, V2, are in counterclockwise direction for the front face. And then the front face of one triangle connects to the front face of the next triangle as you go around. So that's a GL triangle fan. A GL triangle strip, we got done with command GL draw arrays, GL triangle strip. Again, we'll do an example with 6. So for this, we think of the vertices are arranged somewhat differently. So here I've got V0, V1, V2, V3, V4, and V5. And then the triangles that we draw, we sort of think of these vertices being arranged in a ladder type shape. The first triangle has V0, V1, V2, and we're looking at the front face, they go in counterclockwise order. The next one has V1, V3, and V2. The next triangle has V2, V3, V4, and the final triangle has V3, V5, V4. And so, again, you're looking at, these are all front faces. All front faces are showing. So in other words, the front face of each triangle attaches to the next. And the way to think about this is the first triangle, V0, V1, V2, the vertices are in counterclockwise order. The next vertex, V3, is across the edge from V1, V2. So we sort of go over the edge there, and here's the next triangle from V1, V2 to V3. And then we go over the edge between V2 and V3, and here's the next triangle formed also with V4. And then we go over the edge from V3 to V4, and there's V5, which gives us the final triangle. So again, 6 vertices here have specified 4 triangles. So let's do an example of a sphere and how we would draw it with triangles. So I'm going to do 2 versions of the sphere. For the first one, so here's a sphere, right? Here's the equator, here's the North Pole, here's the South Pole. And I want to draw this as triangle strips. So I'm going to put from the North Pole to the South Pole, I'm going to take this wedge off the front of the sphere, and I'm going to split it into triangle strips. So this is going to be like V0, V1, V2. This will be vertex V3. Here's V4, V5, V6, V7, V8, V9. Let's draw the rest of the triangles in here. So here I've got the triangle with V0, V1, V2, then with V1, V2, V3, then V2, V3, V4, V3, V4, V5, and so on up to the top one. In this way, this wedge of the sphere is a single triangle strip. So a wedge or a slice of the sphere is rendered as a triangle strip. And of course, to draw the whole sphere, we'd use multiple triangle strips to render the whole sphere. On the other hand, we could also render a sphere with triangle strips and triangle fans. So let's try this picture here again. So here's our sphere. So now I'm going to think of a slice, a stack of the sphere going around. So here I've got, this is a whole slice running longitudinally around the sphere. And we're going to do this as a single triangle strip. We're going to start with V0, V1, V2, V3, V4, V5, and so on. Eventually we come around, let me suppose we've already made it back around by the time we come to V8, V9. Okay, so we're going to draw this as a single triangle strip. And on this one, the vertices are going to be V0, V1, up through V9, and then we're going to repeat V0 and V1 again. And so the reason for repeating this is that we can draw this triangle strip rectangularly. So here's V0, V1, V2, V3, V4, V5, V6, V8. So V6, V7, V8, V9, and then we repeat V0 and V1. So the vertices at the top are the same as the vertices at the bottom. We've just put them in the array twice. So here we would actually put, if we're using the GL draw arrays command, we would put the starting two vertices into the into the array at the end. So we would convert the loop into more of a kind of a strip. So repeat the first two vertices as the last two. And that gives us a strip going across the sphere, giving the whole thing. We could also put a triangle fan at the top. So here's the North Pole. Let me call that now W0. And around the top we could then put, like, here's W1, W2, W3, and we're building this fan going across. Maybe we end up at W7 and come back to W1. And so for the triangle fan, I'll fit it down here on the board, would use vertices W0, W1, W2, up through W7, and then repeat W1 to close off the last triangle in the fan. So this would end up making, if you had a top view here, would make a closed loop with W0 in the middle, 1, 2, 3, 4, 5, 6, 7. So here's W1 through W7, and it would form all these triangles here. And that would give us the North Pole region of the sphere as a triangle fan. So by putting together these triangle fans and triangle strips, we could also render the sphere in this fashion. Okay, that's the end of this presentation. In the next presentation, we'll talk more about how we work with triangles in graphic systems, especially OpenGL. Thank you.